Our project is the American Sign Language Sign Identifier, or ASL Sign Identifier. The Team Central Park members are Michelle, Wei-Lin, Neil, Brianne, Brian, Abhinav, and Tiana. Michelle was our TA. And why did we choose this product? So our first idea was to have a written language identifier, but seeing as it is already a thing from Google Translate Camera, we decided to shift our focus to American Sign Language. Unlike most languages, American Sign Language isn't quite a written language, so it can't just be plugged into a translator. And this unfortunately causes a divide in communication between the deaf and those who do not understand sign language. So the why is because we wanted to help provide ease of access to translation and to also bridge the gap in communication.
Label box was helpful in many ways, one being enabling us to scan each letter in sign language about 30 times. We got the data from Kaggle but used label box to store the scan information. This is how we processed the data. Although it was tiring to scan each letter of the alphabet over 30 times, with label box we were able to tell the computer which letter the image showed and build a training set from there.
We divided the data set 80% for training, 10% for testing, and 10% for validation. Loss was calculated using intersection over union, and we used the Python modulo operator with the number 10 in order to divide the data set into these three parts. Once we finished testing, we ended up with a 99.67% mean average precision, which was a sign that we had overfitted, since in comparison to a different group, they had a precision rate of around 70%. The algorithm used for training was YOLO, and we ran it through the information to make a prediction. Yeah.
So we evaluated the model using a confusion matrix, as seen on the right. The numbers shown on the diagonal line are the true positives and true negatives of the AI predictions, which are what the AI correctly identified. The stray numbers outside of the main diagonal line, such as the ones or twos on the last row and far right column, are false positives and false negatives, which are AI predictions which are incorrectly identified. Using these numbers, the precision and recall percentages are calculated. In this instance, precision was prioritized because the AI model's top priority should be in identifying the letters correctly. The higher the precision percentage, the lower the rates of false positives are given, which are incorrectly identified letters.
While we were working on this project, the first difficulty that we encountered was that many of us had little experience with Python. To solve this, we split the more experienced coders to hold the backend of HTML and the others to help design a website. When testing our product, we realized that our program is unable to process images that had high definition. This is because our data set is overfitted with low resolution photos. Therefore, when we use high quality images, it focuses on the wrong parts and cannot detect anything. When testing our product, we also find out that the AI is not 100% accurate. This is because some of the letters of the alphabet seem so similar, and some require hand motions to project that letter.
So some of the lessons that we learned is that communication is very important. If you don't communicate well with your project partners, you might end up messing things up, and some problems are a lot easier to solve when you work together. So NicePage and Figma are sites that you use to design how your websites are supposed to look. But NicePage is better than Figma because it actually lets you export your data into HTML. The model training time that it gives you when you start training your model is not accurate. They might say like 20 hours and end up being 40 or vice versa. And so overfitting data can occur when all of your data is similar and you give the model too much time to look at it. So it starts memorizing it instead of like actually learning patterns and stuff. So our model was extremely overfitted with low resolution and fairly dark images. So it doesn't work quite as well with data outside of our data set. So my favorite part of AI Camp was learning how to use HTML to create websites, and creating Python functions for our model.
My favorite part of AI Camp was learning Python and working on the website.
My favorite part was learning Python and solving problems, and I really enjoyed coding for the project as well.
My favorite part of AI Camp was getting more familiar with Python, as well as learning about deep learning process firsthand, and watching our ASL sign identifier work. So that's pretty cool.
My favorite part of AI Camp was learning how to utilize the YOLO repository and the useful libraries related, and seeing the projects the TAs made. My favorite was the one AI that was designed to draw the creator's face.
My favorite part of AI Camp was actually using CodeCalc. I found this website to be extremely useful.
All right, and here is our website. I actually really like the design we ended up with. So here's the top part of it, American Sign Language. This is where you would import any images that you want to be scanned. Down here, we have the project overview, which tells you what it's for best results, which we mainly had to include that because of how overfitted our data was. And then our applications for the model. And we also have a chart of the alphabet for sign language. It has each of the letters. You can see J and D. Those both require movement, so those are a bit wonky. We have the resources we used, and these are our bios. So we got Michelle, who's best TA ever. Michelle, you're great. And there's our beautiful people. And then this will connect you to the AI Camp website, just generally. So for importing your images, you can choose whatever image you want, and it'll process it, bring you to the results page, and it'll tell you what letter it found S, which is right, and it had 34% confidence. You can see the bounding box around it. So we did have some problems, like high resolution or any overlays over the hands will make sure it won't really detect anything if you have high resolution or big pictures, because our pictures were also fairly small, so any large files don't really work well. You can see that it doesn't find any objects with these types of ones. Anyways, that was our project. Thank you for listening.